Over scalar and vector projections. I think specifically in this video we'll just focus on the scalar one to start, and we'll do a completely separate one for vector projections. So we're going to be looking at this formula here, which is very, very similar to the dot product. Okay, and we can, in fact, we can prove it after. But we're going to be looking at a scalar projection of A on B. So this is specific scalar projections. What that means as a vector or as a visual, I want you to think of it kind of like this. If this is our A vector and this is our B vector, okay, the scalar projection will be a magnitude or a value of the A vector projected on the B. So almost like this entire space here, we'll get a value for it. Okay, that's what a scalar projection is, and I'll use a dotted line to represent that. Kind of like a shadow. It's a great way to think of it. Okay, so this being our formula, we have a question down at the bottom, and a point in our formula that we should know that a scalar projection of A on B will not be equivalent of a scalar projection of B on A. Okay, they'll be very different. They won't be equal, and we're going to do an example of both. So we have an example down here of two vectors in 3 space. Okay, don't worry about the rest of that stuff. We'll go over it after. We have our 2 vectors here. We're going to calculate a scalar projection of A on B and B on A. Before we do that, actually, like I said, I would like to show you guys the proof of that dot product. So if we have A dot B is equal to the magnitude of A times the magnitude of B times cos theta. Okay, we're looking for, if you go up again, will it go up? There we go. We're going to be setting this equal to the magnitude of A times cos C. That would be our scalar projection of A on B. So the idea here, and I'll highlight the 2, is we're just isolating the magnitude of A and our cos theta. So really, all we need to do is move over our magnitude of B to the other side. So we end up with our formula. I'll show you it again at the top. Okay, of our magnitude of B on the bottom. And we have our scalar projection formula. So it's just moving around the dot product. Okay, that's the idea to it. So if we're doing a scalar projection of A on B, we're looking for A dot B divided by the magnitude of B. Okay, so we have our vector A and our vector B. If we're going to find the dot product between the 2, we're going to multiply our x values together, our y values together, and our z values together. We'll add them all together, and that will give us a scalar or a number, which will be the dot product for the top of this fraction, or the numerator. Okay, so we're going to do that quickly. Our dot product of A dot B. Negative 3 by negative 2 is going to give us 6. Okay. 4 by 2 will give us 8. And this will give us a negative 5 times root 3. We'll put them together. 14 subtract 5 root 3. We'll have to use a calculator to get this part. Where's my calculator? We have 14, oh, actually I can't do it that way. Root 3 times 5, 8.6, 14, subtract 0.66, 5.34. Okay, 5.34 is our dot product for A and B. So that would be the value we'll have on the top of our formula, 5.34. The second thing we have to find is the magnitude of B. Okay, so I'm going to write down our vector B again, the coordinates of it, which were negative 2, negative 2, 2, and 1. Now I have to think of a quick way to find the magnitude of B. Now if you guys remember, if we do the dot product of B on B, does anyone remember what that gives us? From yesterday in the afternoon? Magnitude of B squared, okay? So what that is saying is if we find the dot product of all of our values, it will give us the magnitude of b squared. So to find the dot product between the two, we're going to multiply our x value by our x value, our y value by our y value, and our z value by our z value. Think of it like we're squaring them. That will give us the magnitude of b squared. So that's a quick way to find the magnitude of this vector. So the magnitude of b squared is equal to negative 2 squared, I guess we'll write it out that way, plus 2 squared plus 1 squared, which means the magnitude of b squared is equal to 449. Great. But that's not just the magnitude of b. We need to isolate for the magnitude of b, which means we need to find the square root of 9, which means the magnitude of b would be a value of 3. So the bottom of our formula now is the value of 3. Okay? So we take these numbers, go down, and we divide the two, and we'll have our scalar projection of A on B. There it is, 5.34 divided by 3, 1.78. Okay? So that is our scalar projection of A on B. Let's try the reverse now. Give me a sec. Okay, so our scalar projection of B on A, this is going to change our formula a little. Okay, our formula that we had before was written like this, and this was for A on B. The dot product will still stay the same on top, but what will happen if we're looking for B on A, we'll have A dot B over the magnitude of A. Okay, so this is going to change depending on which vector we're finding the scalar projection on of the other. It will change our formula. Okay, so think of it as whatever is being projected on, that will be where we're dividing by its magnitude in this question. So let's scroll back down. No, that's up. There we go. It's getting dizzy. Up a little, please. Our formula reading A dot B over the magnitude of A. We'll speed this part up again. What is our A dot B? Anyone remember? Yeah, 5.34. So this value stays the same, the top of our fraction. So we already have that. We have 5.34. We need to find the magnitude of A now. And the same way we did before, we're going to find the dot product of A and A, which will give us the magnitude of A squared. Okay? So essentially, we're going to square all of these and then find the square root. So instead of stepping through everything, I'm just going to quickly set it up in one step. No, I want that. So we're looking for the square root of negative 3 squared plus 4 squared plus 5 root 3 squared. Okay, all in brackets there. Which will give us the root of 9, 16, and 75. Is that right? Someone want to check that? 16 and 75. Yeah, we're okay. Put those together, what are we going to get? 2,500. Are we looking at a root of 100? All right. Beautiful. So our magnitude of A will be 10 in this question. So we'll be dividing by 10, which will give us what value? That's it, 0.534. So our scalar projections are very different depending on whether we do a projection of B on A or a projection of A on B.